Is basically an examination of the controller Python code for the CrazyFlie. You talk to this Python program through sockets from the EEK. So I also have some of these other smaller examples kind of queued up to at least show. These are all lesson Python files that you can see in the lesson resources. So the first one is the very small example at the very beginning that you can run if you've got a CrazyFlie at your disposal to make sure that the CrazyFlie is controllable from your Python and you've got the installs for the needed libraries. And then this is just a slightly more complex command that does more than just take off and land. Again, these are motion commander commands. This is not using the EEK. This is just directly flying from Python. We got a few print messages, but not many print messages. And then the one more complex example is to fly a circular flight plan pattern. So as the comment here says, the definition of the circle command, move circle simple, flies in a circle from left and right, requires a 1 meter work area to run successfully so you don't bump into things. And then it has a 0.5 second delay between each movement. Now again, these are actually provided to you, and if you have a CrazyFlie, you can have some experience with it. But then this is the one I want to concentrate on because this is the Python file that you run on your host. You have to name the UDP IP port that your host is running at. So you look that up through the network interfaces of your host, either Mac or Windows. And then again, just for convenience sake, I keep using the same UDP port as the Tello 8889. And then these initialization steps are the same as I got from all of the motion commander examples. And then I'm not going to talk through the logic here, but there was a fair amount of time spent by me looking at some of the documentation on the CrazyFlie sites to try to understand what the battery state is. Because with the CrazyFlie, it's basically, if it's red, if the one indicator light on the CrazyFlie is red, that means your battery state is good. And then when that red light, which is kind of a healthiness light, if that starts to blink, then that means you're running low on battery and therefore you should land. And that wasn't good enough to me because we have better battery management with the Tello. So I tried to do something here, and again, if you wanted to learn more about this, you would poke around in some of the documentation files that I linked to from the module text. But then the main command is move with EEK, and you pass in there an object, and then using that object, you can then do the context-sensitive way. Well, actually, this isn't the context manager way. This is using it directly, using the motion commander directly, using that higher level context object, which comes from the main method. And then there's a default height. And then while true, you're listening for commands. Those are commands coming from the EEK. So again, the EEK commands will send velocity commands based on gestures or based on buttons. And so stop is a command from the logic of the EEK, and then land is a command from a button. And then these other commands come from the velocity versions come from the buttons. The up without the velocity and the down without the velocity, those would come from flight path functions. Or if you had the serial monitor open on the EEK, you could be sending these distance commands down and have the Python CrazyFlie controller pick those up and fly. And then there is the CCW circle method, CCW circle message, which causes circle left to fire. And then there's the CW circle message, which causes the circle right to fire. And then these are all of the go commands. Basically, I'm assuming you're going to be using the gestures to generate each one of these commands as you manipulate the EEK over your manipulation of it. And again, there's a CCW V version, so a velocity CCW command and a non-velocity command. And then there's a short quick method. Again, I just picked this up from sample code that detects whether or not the flow control deck is attached. And you really don't want to try the CrazyFlie unless you have a flow control deck attached. So this kind of just checks that it is. It's actually detected that it's really there. And then in the main program, you initialize your drivers for the CFlib capability, and then you're using the context manager style again, as we saw in some of the other Python examples, with sync CrazyFlie, and then the URI is the radio, as I believe it. Yeah, that's the radio, and that's the radio. Kind of looks like a HTTP, kind of looks like a URL. And then we're using the radio from the Python on the host to talk to the CrazyFlie. I don't have a Wi-Fi connection to the CrazyFlie, and although I know there is such a thing as a Bluetooth connection to the CrazyFlie, I haven't been able to figure out how to use it. And then we do some logging setup for battery management, and then we go off and call the main method, which is move with EEK, using the SCF sync CrazyFlie object that we set up in this with context manager kind of code, and that's it. So again, if you have a CrazyFlie, I really would ask that or suggest that you try to fly the CrazyFlie using this code with the EEK involved as well.